Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab. Now in the super crash course, we are starting with the concept of modulus function. Modulus function, the official name is absolute value function. So modulus means absolute value. This is part of the topic of algebra. So in algebra, there are 4 subtopics. Let me list them down. The first subtopic of algebra, that is what we are doing right now. That is modulus function. You can study them in any order, no issue. The second one we will study is binomial. The third one that we will study is partial fractions. And the fourth one, that is polynomials. It's about cubics, power 4, long division, and so on. So this is basically topic 2 in the order that we are studying. Topic 1 was logs and function, logs and exponential that we completed in 2 classes of 75 minutes each. So now let's get over this first thing, which is modulus function. And inshallah ta'ala, it will take only 1 class. Now, first of all, when we talk about absolute value, if there is a value of positive 3, the absolute value is 3. If there is a negative value, when we take the magnitude, we take the length. So this also comes out to be 2. If we take magnitude of 0, it remains as 0. So what is the function of modulus? Modulus, a positive, remains as positive. Negative becomes positive. 0 remains as 0. That is the basic idea of modulus. Now, if I talk about modulus equation, so let's first talk about mod equation. If I say modulus x is equals to 3, that means there are 2 possibilities. Either the thing on the inside, this one, this modulus could have been positive. This thing inside could have been positive. So x was positive or this x was negative. In any case, the absolute value is 3. Therefore, from the first equation, x is 3. From the x equation, x is negative 3, which makes perfect sense. Magnitude of positive 3 is 3. Magnitude of negative 3 is also 3. So technically, we are getting a plus and a minus. In other words, if I say modulus x equals to a constant a, that means x with a positive sign equals to a. I'm deliberately writing it in an expanded form rather than a shortcut. Therefore, x is equals to a and x with a negative sign equals to a. Therefore, x is equals to negative a. Let me elaborate on this. X plus 1, the whole thing, modulus equals to 4. Maybe x plus 1 with a positive sign equals to 4 or x plus 1 with a negative sign equals to 4. So therefore, x plus 1 equals to 4, x is equals to 3, or negative taken to the other side, x plus 1 is negative 4, therefore x is negative 5. Plug in and double check. 3 plus 1, 4, modulus of 4 is 4. Minus 5 plus 1, negative 4, modulus of negative 4 is also 4. So that is the basic idea of modulus equation. Now let's move to modulus inequalities. And let me make 3 cases out of it. So when I talk about modulus inequality, let me explain you the first case. So case number 1, that is of the format Modulus x less than or equal to a doesn't make a difference. If it's less or less than or equal, it doesn't make a difference. Now, if I expand it just like this, the x could be positive, the x could be negative. So let me first write it like this. Modulus x less than or equal to a, two options are there. X is positive, less than or equal to a. X is negative, less than or equal to a. This remains as it is. This becomes x is greater than or equal to negative a. Let me draw a number line. And over here, I'm labeling a. Over here, I'm labeling negative a. X is greater than or equal to negative a. So now we are moving for this thing. Actually, for this thing, I'm writing this negative one first. For this thing, we are moving to the right. Solid circle, go right. For this thing, x is less than or equal to a. Solid circle because it's inclusive, and go left. So now the overlapping region is the answer. That is the overlapping region. So therefore, x lies between negative a and positive a inclusive. So whenever we have modulus x less than or equal to a, that can be written as x lying between negative a and positive a. So next time, we don't have to go through the basics. We can simply quote the result. And what is this double arrow? What does it mean? This can be written as this. This can be written as this. Now let me take you back to down the memory lane. When in P1, you did sum to infinity. Common ratio lies between -1 and +1. So now when you look in the formula sheet, this is written as R modulus is less than 1. Why? Because this thing can be written as this or vice versa. So that is a perfect example of the application of modulus. Let me rewind it and tell you once more. Whenever there is a modulus x less than or equal to a, x lies between a and negative a. Now keep in mind, this modulus has to be on the left hand side of the equation. This is case number 1. And it could be less than or equal to a, it could be less than a. If it's less than a, it would be written as less and less over here. Nothing else will change. That is the first case. Now let me do some examples of first case. So case number 1, let me write it again. X modulus less than or equal to a can be written as x lies between negative a and positive a. For example, modulus x less than or equal to 4, just open up the bracket. Therefore, x lies, the modulus is removed. X lies between -4 and +4. X plus 1 modulus is less than 3. So therefore, x plus 1 lies between 3 and -3. And since it's only lesser, so there is no equality over here. Make x the subject, therefore subtract 1 from both sides. This is 3 minus 1. This is -3, -1. Therefore, x lies between -4 and +2. Two examples. So this is basic worked example 1. This is basic worked example 2. Let me do one other example. Worked example 3. 2x plus 3 modulus is lesser than x plus 1. First, write it in the proper format. 2x plus 3, make a bracket, lies between negative of x plus 1, positive of x plus 1, just like the original thing, this one. Now, in order to solve it, you cannot solve it in one shot. So solve this separately, solve this separately. Now the blue one, just this negative is opening one side, negative x -1 is lesser than 2x plus 3. And negative x -2x -3x is lesser than 3 plus 1 is 4. Therefore, x is greater than, the inequality flips, that is negative 4 over 3. Similarly, when you solve the red side, 2x plus 3 is lesser than x plus 1, 2x minus x, that is x is lesser than 1 minus 3 is negative 2. So now there is negative 2, x is lesser than negative 2, x is greater than minus 4 over 3. Just draw a number line. So now negative 2 is a smaller value. So negative 2 is extreme left. And then negative 4 over 3 is like this. And also double check inequality. Yeah, this one has flipped. So x is greater than minus 4 over 3. That is going towards the right. X is lesser than negative 2. That is going towards the left. So final answer, since there is no overlapping region, so final answer is two separate inequalities. X is lesser than negative 2. X is greater than minus 4 over 3. Have a good look at this page, especially worked example number 3. And I'm writing on the WhatsApp group. So now case 1, that is all good, all clear. Okay, Ji. That's the first thing. Okay, now let's move ahead. Case number 2. And let me add few more pages over here. After we are done with all the cases and the graph that I won't, I might do it now, but basically that graph, I can do it in numerical solution also. So now over here, secondly, let me focus on case number 2. And let me just check one thing, which I always do. That is the recording, and it's all good, all clear. So now case number 2, that is x modulus is greater than or equal to a. What will it become? Let's see. X modulus greater than or equal to a. X could be positive, greater than or equal to a. X could be negative, lesser, greater than or equal to a. This remains as it is. This one will change. X is lesser than or equal to negative a. Now draw a number line. Mark a, which is positive. Mark negative a, which is negative. And greater than or equal to a. So it's going to the right. Lesser than or equal to negative a, it's going to the left. Two separate inequalities, both are the answers. Therefore, x is greater than or equal to a. And this one is x is lesser than or equal to negative a. Do not write and, do not write or, just put a comma. So that is case number 2. That means when we open up the bracket, x is less than or equal to negative a, x is greater than or equal to positive a. Again, modulus x is on the left hand side. That's case number 2. That's a hard and fast rule. And it could be about greater, it could be about lesser. Now let's compare case 2 and case 1. Case 1, x modulus lesser than or equal to a. It becomes a single bracket. Maybe the final answer would change. That's not up to us. That's not the issue, but we will write it in the proper order. Similarly, case number 2, x modulus on the left hand side greater than or equal to a, it will be written initially as two separate inequalities. Now the worked examples of case 2. So case 2, worked examples. Worked example 1, very basic. X modulus greater than or equal to 5. This will be written as x lesser than or equal to negative 5, x greater than or equal to positive 5. Very simple. Worked example 2. 2x plus 3 modulus is greater than 7. 2x plus 3, write a bracket lesser than negative 7. 2x plus 3 in a bracket greater than positive 7. 2x is lesser than negative 10, x is lesser than negative 5, 2x is greater than 4, x is greater than 2. Draw a number line, mark the points. This is 2, it's going to the right. This is negative 5, it's going to the left. There is no overlapping region, no overlapping region. Therefore, both are the answers. So this is the answer. This is the answer. That's the final answer. Now let's move ahead and let's move to case number 3. But before case number 3, let me recap P1, quadratic inequalities. First of all, when we solve a quadratic inequality, two things are necessary. The factorized form of quadratic equation that is necessary so that we are able to look at the roots. And the second thing, sketch based on factorized form so that we can write inequality by looking at the sketch. And in P1, that is what I used to say, drawing a sketch is a must. So this is M, this is U, this is S, and this is T. So drawing a sketch is a must. What kind of sketch? A quadratic sketch based upon factorized form. So factorized form of quadratic equation to get the roots, to get the sketch. So drawing a sketch is a must to solving quadratic inequality. It cannot be solved algebraically. That is it, period. Let me do one simple example. X plus 1, x minus 2 is less than 0. X plus 1, actually another equation. X square minus 5 is greater than or equal to 0. Two separate things. So let me draw a line in the middle to show that these are two worked examples. Let me push this to the corner. Let me push this line also over here. Okay, first thing, it's already factorized. Draw the x-axis, draw the x-axis, draw the curve, and draw the curve. Make sure the coefficient of x square is 1 so that it is always a happy face curve. So let me write over here. Make sure coefficient of x square is positive. Therefore, this will always be a happy face curve. If it's not, multiply with a negative sign, flip the inequality. Now it's already factorized. So therefore, this minus 2 is plus 2. This plus 1 is negative 1. The other one is not factorized. So you have to factorize it. So just do a little bit of factorization. So now over here, this is x plus root 5, x minus root 5. You cannot take 5 to the other side and take the square root. That is not possible. Now it's factorized. So now over here, it says less than 0. Less than 0 means region below x-axis. So that is this region. One single region. Therefore, one single inequality. Therefore, x lies between these two values, which is -1 and +2. That's how you solve it. Very simple. Over here, this is -√5. This is +√5. This is greater than or equal to 0. This is region above x-axis. So region above x-axis, this is two separate region, two separate answer, two separate region. Therefore, two separate inequalities. Answer is inequality. You go extreme right, you go extreme left. X is lesser than or equal to -√5. X is greater than or equal to +√5. So just have a good look over here, what I have tried to explain. So case 1 is done. Case 2 is also done. And the concept of chord inequality that I have explained. So just acknowledge if this is all got all clear. Okay. So now, why have I taught this? So that we can solve case 3 using this method. That is the reason for solving this. So now over here, case number 3, let me label this. So now case number 3 is modulus on both sides. Inequality could be lesser, lesser than or equal, greater, greater than or equal, no issue. The rule is square both sides. Why do we square both sides? Because positive remains as positive, negative becomes positive, 0 remains as 0. That is the logic over here. When we square both sides, we will get either a linear inequality or we will get a quadratic inequality. For quadratic inequality, sketch-based answer. For linear inequality, that is basic maths, nothing special. So now, let's get started with the past paper questions. And the very first question is about this. Now, there is one query that people ask, and that is about the sketch of modulus function. Is that in the syllabus? Yes, it's in the syllabus. Let me write it down. So first thing first, yes, sketch of mod function. Yes, it's part of the syllabus. Secondly, some people, they use the sketch to get the answer. Of course, it's a sketch, so calculation is also there. Some people don't use it. So I'm the one who don't use the sketch for solving inequality. So a stand alone sketch question, of course, I'll tell you how to solve it, how to make that sketch. But I don't use mod sketch to solve inequality because from my perspective, that's a waste of time. I use the three cases, case 1, case 2, case 3 to solve mod inequality, and that is more than enough. That is more than perfect. Now, if I make a summary sheet, what is that summary sheet? That summary sheet is what are the three cases in one shot. So now, modulus inequality, case 1. Modulus x less than or equal to a. When I expand it, x lies between -a positive a. Case 2, modulus x greater than or equal to a. When I expand it, x is less than or equal to negative a. X is greater than or equal to positive a. Case 3, modulus on both sides. So you don't have to worry about which side, which inequality, doesn't make a difference. Greater, greater than or equal, lesser, lesser than or equal. Over here, we square both sides. And either we end up with a linear inequality, we end up with a quadratic inequality, and then we solve it accordingly. It's as simple as this. Yes, what is necessary? Modulus on the left hand side in case 1 and less than or equal to. What is case 2? Case 2 is again modulus on the left hand side greater than or equal or greater than. So you expand it this way. And what is case number 3? Case number 3 is mod on both sides. What is the rule? The rule is square both sides, and you actually square it. Keep in mind, it's not a square root. You actually square it. So now this thing is done. Let's go to the questions. The first question, solve the inequality. This is 2x minus 1. Let me just cut it and then paste it. I don't know why is it turning hazy. Okay. 2x minus 1 modulus is greater than 3 times x plus 2. Now first decide the case. Is it the first case? That is case number 1. Second case, that's case number 2. Third case, that's case number 3. Let me just copy red, blue, and green. And let me just write over here. That is case 1, that is case 2, that is case 3. Let me copy this key and we will be pressing one of the buttons. So this is this question, and then there is this one. Then there are different types. This one has a sketch, but first I won't draw the sketch. I'll draw sketch at the end. And since you also have access to my regular lectures, so over there, I mean, you can also go through this topic once again in the regular mode. So that's the maximum kind of thing that I'm doing for you people. And there are many varieties in this one. And I think that is about it. Okay, so now let's decide. Case 1, case 2, case 3. Which one is this? This is case 3 because this is modulus on both sides. So modulus on both sides, that is case 3. Case 3, square both sides. 2x minus 1, the whole thing square, greater than 3 times x plus 2, the whole thing square. That is the first step. Square both sides. The modulus disappears. Expand 4x square. Let me make it thinner. 4x square minus 4x plus 1 is greater than 9x square plus 4x plus 4. Go very easy, no hurry. 4x square minus 4x plus 1 greater than 9x square plus 36x plus 36. 0 greater 9 minus 4, or let me take it to the other side. And then I want to illustrate that when you multiply with a negative sign, inequality flips. So I want to illustrate this concept. 4 minus 9, negative 5x square. Minus 4 minus 36 minus 40x. 1 minus 36, negative 35 is greater than 0. Multiply with a negative sign. So this is 5x square plus 40x plus 35 is lesser than 0. The inequality has flipped. The signs have changed. The inequality has flipped. No harm in double checking. 4 minus 9, negative 5. Minus 4 minus 36, negative 40. 1 minus 36, negative 35, all good. Let's also divide by 5. Let's simplify our lives. X square plus 8x plus 7 is less than 0. And most likely, it will be done through middle term factorization. So let me just adjust this. Okay. So this is x square plus 7x plus x plus 7 is less than 0. X bracket x plus 7 plus 1 bracket x plus 7 is less than 0. So therefore, this is x plus 7. This is x plus 1 is less than 0. And then let's draw a number line. Let's draw a simple sketch. There is no y-axis that's needed, just like I have taught you P1. So this is negative 7. This is positive 1. It says less than 0. That is the region below the x-axis. One single region, one single answer, one single inequality. X lies between negative 7 and plus 1. Have a good look at this working. So now, first past paper problem. Is this all good, all clear? So this is case 3. Okay. So now this is good. Let's move on. Look at the final answer. Don't look at the method. Just look at the final answer. They are talking about critical method and graph and all these things. Just ignore it. So just look at the final answer. Now, question number 5. Which one is this case? Again, this is case number 3. Why? Because this is modulus on both sides. And don't forget to modulus to square this side. And these two questions look very similar. This is 2x minus 1, 3 times x plus 2. This is 2x minus 1, 3 times x plus 1. Now, let me pause the recording. I want you people to solve it. So just take 3 minutes and solve this particular question. So now, the same type as the previous. Square both sides, and someone just pointed out that there might be a mistake. Okay, hold for a second. Small mistake over here. Plus 1 becomes negative 1, and this is negative. So black marker, and this is negative. There was a correction over here. I did it. Now let's move on. It's the same thing. 2x minus 1 whole square is lesser than 3x plus 1 whole square. That is 4x square minus 4x plus 1. This is 9 times x square plus 2x plus 1. And this is 4x square minus 4x plus 1 lesser than 9x square plus 18x plus 9. Take it to the other side. 4 minus 9, negative 5x square minus 4 minus 18, negative 22x. 1 minus 9 is negative 8 lesser than 0. This time I cannot simplify except for the negative sign. So 5x square plus 22x plus 8 is greater than 0. So just focus on this, that this is greater than 0. Lesser becomes greater. And now factorize. 5 into 8 is 40, 20 into 2. 5x square plus 20x plus 2x plus 8 is greater than 0. 5x bracket x plus 4 plus 2 bracket x plus 4 is greater than 0. This is x plus 4. 5x plus 2 is greater than 0. A small number line and then a sketch. And plus 4 becomes negative 4 plus 2 over 5, negative 2 over 5. Okay, so therefore this is negative 4. This is negative 2 over 5. Greater than 0 is the region above x-axis. Two separate region, two separate answer. Extreme right, extreme left. X is lesser than negative 4. X is greater than negative 2/5. Double check. Lesser than negative 4, greater than negative 2/5. All good, all clear. Now this one has the sketch, but it does not pressurize you, emphasize you to solve using the sketch. So for right now, let's wait for it and just focus on the second one, part B. So now it says, excuse me, 3x plus 5 is lesser than 2x plus 1. Don't decide yet. First, write it properly. 2x plus 1 modulus is greater than 3x plus 5. Why? Because it's a condition that you write modulus on the left hand side and then decide the case. Modulus on the left, greater sign, that is case number 2. So now this is case number 2, which is that case 2, modulus x greater than a, that is the same thing as x is lesser than negative a, x is greater than positive a. So this is your a. So therefore 2x plus 1 is lesser than negative of 3x plus 5, and 2x plus 1 is greater than 3x plus 5. Double check. This one, x is greater than a, that is over here. This one, x is lesser than negative a, that is over here. Okay, all good. Now expand and simplify. Let's see what happens. 2x plus 1 is lesser than negative 3x negative 5. 2x plus 3x, 5x is lesser than negative 5, negative 1, that is negative 6. Therefore, x is lesser than negative 6 over 5. All good? And over here, 2x minus, let me write it first. 2x plus 1 is greater than 3x plus 5. 2x minus x is negative x is greater than 5 minus 1 is 4. Therefore, x is greater than negative 4. So x is greater than negative 4, x is lesser than negative 6 over 5. So let's draw a number line. Negative 4 is the smaller value. Negative 6 over 5 is the greater value. X is lesser than negative 6 over 5. So this one, x is lesser than negative 6 over 5. X is greater than negative 4. Now it so happens that they are moving towards each other. So therefore, overlapping region is the answer. X lies between negative 4 and negative 6 over 5. That's the answer. So you should draw an inequality in case 1 and case 2. You should draw a number line in case 1 and case 2. If they are moving away from each other, that is the answer. If they are moving towards each other, overlapping region is the answer. So if they are moving towards each other, then overlapping region is the answer. So that is the case. So hold for a second. I think I might have made a small mistake. Let me just double check. 2x plus 1 is greater than 3x plus 5 minus 3x minus 5. 2x plus 3x is 5x minus 5 minus 1 is negative 6. X is lesser than negative 6 over 5. That is good. 2x plus 1 and this thing x is, oh, I forgot to flip the inequality, my bad. This inequality is not flipped. So now we will have a new scenario over here. Just hold for a second. It's not moving towards each other. It is moving in one direction. So my bad, and this is x is greater becomes lesser than negative 4. So now over here, yes, I need to draw the number line. And this is negative 4, that is the smaller value, negative 6 over 5. Now let me draw with a red line first. X is lesser than negative 6 over 5. Hold for a second. Let me draw this like this. This is this. And this green one, x is lesser than negative 4. X is lesser than negative 4. That is this region. Now there is an issue. The issue is both inequalities are moving in same direction. Now, what do? We apply the true false test. Okay, so now let's choose a value which is somewhere over here. Negative 4, negative 6 over 5. Let me choose a value negative 2. Let me choose a value negative 5. And let's plug in, let x is equals to -5. Let x is equals to -2. Plug in the original inequality, which is this. 2x plus 1 modulus is greater than 3x plus 5. 2x plus 1 modulus is greater than 3x plus 5. When I choose x is equals to -5, what happens? 2 times -5 plus 1 modulus, is it really greater than 3 times -5 plus 5? -10 plus 1, -9, modulus of -9 is 9, greater than 3 into -5, -15 plus 5. -15 plus 5 is -10. Is 9 greater than -10? The answer is yes. That means this part of the inequality is true. So this is lesser than -4. That is true. That means if you try for -6, if you try for -60, still it would be true. This is a representative. If I choose this value, which is -2, and plug it in over here, so this is 2 into -2 plus 1 modulus. Is it greater than 3 into -2 plus 1? So -4 plus 1, -3 modulus, which is +3, greater than 3 into -2, -6 plus 1, which is -5. Yes, this is also true. 3 is greater than -5. So now this thing is also true. If both inequalities are true, this one is including this thing. So therefore, the final answer over here, the final answer over here is the overlapping region, is the total region, that is x is lesser than -6/5. That is the answer, x is lesser than -6/5. So just go through this thing. After you get both inequalities, they are in the same direction. So now what happens? Two inequalities. Two inequalities moving in same direction. So we apply the true false test. We choose two values. We plug in original inequality and check. If it satisfies both, therefore, we will say that this is taking care of both the thing. Therefore, this is the answer. Now, some people, they ask this question, and which is a very genuine question. That is, what if this was true and this was false? Then only this thing is the answer. X is less than -4. What if this is true and this is false? Then this region would have been the answer. So whichever value is taking care of that particular region, that is the answer. Only this, that means only this is the answer. Only this, from this is true and this is false, then only this region is the answer. This is true, therefore both things are the answer. Now let me just give you one question. I hope this is the same type. Yes, it's the same type. And why don't you just try this out? Let me pause the recording. Now this and recording is paused. So now let me solve this particular question. First thing first. That is the modulus on the left hand side? Yes. There is a lesser sign. That means this is case number one, modulus on the left hand side, lesser sign. So therefore, I'll write x minus 3 modulus is gone. It lies between two values, negative of something, positive of something. What is that something? 3x minus 4, 3x minus 4. Solve this separately. Solve this separately, and then we will see how it goes. So the blue region, negative 3x plus 4 is lesser than x minus 3. Negative 3x, negative x, that is negative 4x. And negative 3, negative 4, that is negative 7. Two negative signs, but inequality will still flip. So x is greater than 7/4. This one, x minus 3 is lesser than 3x minus 4. x minus 3x negative 2x is lesser than negative 4 plus 3, that is negative 1. Therefore, x is greater than half. So now I'm successful. I did not forget to flip the inequality. Okay. Now draw a number line. And when I draw this number line, what do I see? I see they are both moving in the same direction. This is half. This is 7 over 4. Let's say this is the red one. X is greater than 7 over 4. It's moving towards the right. Let me choose this one. X is greater than half. This is also moving towards the right. So if it's moving towards the right, what do? We apply the true false test. Simple rule. So now let me choose this thing. Half and 7 over 4. So let me choose a value 1. Let me choose a value 2. So now this 1 is a representative of the blue line. So let x is equals to 1. This 2 is a representative of the red line. Let x is equals to 2. And this 1 is a representative of the blue line for this region. This 2 is for the red line. If both are true, will be the answer. If only this thing is true, then only this is the answer. If only this is true, then this will be the answer. Very simple. Now plug in original inequality, which is x minus 3 modulus is lesser than 3x minus 4. X minus 3 modulus is lesser than 3x minus 4. If I plug in 1, that is 1 minus 3 modulus, is it really lesser than 3 into 1 minus 4? 1 minus 3 is negative 2 modulus, which is 2. And this is 3 minus 4. 3 minus 4 is negative 1. Yes, this is correct. 2 is this. My bad. This is a magnitude of 2. Let me just check. Did I plug in 1? Yes. 3 minus 4 is negative 1. And is the inequality lesser? Yes, the inequality is lesser. 2 is not lesser than minus 1. Nope, this is false. Let's plug in the other one. So now let's plug in 2. 2 minus 3 modulus, that is negative 1 modulus, which is 1. This is lesser than 3 into 2 minus 4. 3 into 2 is 6. 6 minus 4 is 2. 1 is lesser than 2. Yes, that's true. So now this is false. This is true. That means only this is the answer. Therefore, the final answer is x is greater than 7 over 4. That's the final answer. X is greater than 7 over 4. So now we have done 2 questions related to inequalities moving in the same direction. Now this one, the same type. Let me write it down. First modulus 2x minus 3 modulus. This is lesser than 2 minus 5x. Divide by 2. X minus 3 modulus is lesser than 1 minus 5 over 2x. All good? So which case is this? First of all, we have to make sure modulus should be on the left-hand side, lesser, 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 all good. Get rid of 2 by dividing by 2. Now, left-hand side and lesser. So therefore, this is case number 1. How will you write it? You will write x minus 3 lies between 1 minus 5 over 2x, and this is negative of 1 minus 5 over 2x. Let's also solve this. So now I'll solve this separately. Negative 1 plus 5 over 2x is lesser than x minus 3. And 5 over 2x minus x is lesser than minus 3 plus 1. 5 over 2 minus x, that is 3 over 2x, is lesser than minus 2. Therefore, x is lesser than minus 4 over 3. Okay. Now, the other one, that is this. X minus 3 is lesser than 1 minus 5 over 2x. X plus 5 over 2x is lesser than 1 plus 3. 2 plus 5, that is 7 over 2x is lesser than 4. Therefore, x is lesser than 4 twos are 8 over 7. Okay. And over here, they both are moving in the same direction. Yes, again, the true false test. So this is the third question that we are looking at. So now, 8 over 7 is positive. Yes, and this is negative 4 over 3. A red line for this, lesser than 4 over 3, going in this direction. Purple line for 8 over 7, that is going in this direction. And let me just change the purple color. Let me choose different color. That's very common. Okay. So now negative 4 over 3, anything lesser. So negative 2, I think that's a good number. So let me choose this thing, negative 2. Let x is equals to negative 2. And between 8 over 7 and 4 over 3, let me choose a value 0. Let x is equal. So now let's plug in and check. When x is negative 2, where do we plug in, by the way? We plug in the original inequality, that is x minus 3 modulus. X minus 3 modulus is lesser than 1 minus 5 over 2x. Let me write it twice so that there is no confusion in where I am plugging it in. So this is minus 3. Let me just plug in the value a little bit later. 5 over 2. This is minus 3, lesser than 1 minus 5 over 2, somewhere over here. So I'm plugging in negative 2 over here. I'm plugging in negative 2. And over here, I'm plugging in 0. I'm plugging in 0. So keep in mind that negative 2 is a representative of this inequality. 0 is a representative of this inequality. If both are true, this will be the answer. If this is false, this is true, only this will be the answer. And if this is false, this is true, then only this will be the answer. There are only three options. Now look at the first one. Minus 2 minus 3, that is negative 5. Modulus is it lesser than 1 plus 5. So this is 5. This is lesser than 6. Yes, this is true. Good. Over here, 0 minus 3 modulus, that is negative 3 modulus, which is 3. This is 1 minus 0. This is 1. Is 3 lesser than 1? Nope. This is false. So therefore, only the red inequality is true. Therefore, the final answer is the red inequality, that is x is lesser than, which one is it? Negative 4 over 3. Let's double check. X is lesser than negative 4 over 3. So that is the true false method. We did 3 questions. So that's a one, that's the maximum, which people find it difficult, and so on. Now, 2 more questions to finish it off. And keep in mind the modulus graph that I'll do in linear inequalities, all the graphs in one shot. Find in terms of A, the set of values satisfying this inequality. Now, what is special about this? First of all, there is modulus on both sides. So therefore, this is a scenario of case number 3. Modulus on both sides, square both sides. The special thing is A is a positive constant, so you just have to deal with a constant. So 2 bracket 3x plus a, the whole thing square is lesser than 2x plus 3a, the whole thing square. So this is 4, this is 9x square, and the battery is running low. So let me just charge it. And let me just check one thing. That is the recording on. Yes, the recording is on. So now you have to solve this out. So let me move. 9x square, 6 plus 6, that is 12x plus a square, bracket closed, lesser than 4x square. 2 into 3 is 6, that is 12ax. And yes, there is an a over here. So let me just correct myself. And let me push this thing a little bit further away. that is 12ax. Don't forget the a. This is also 12ax, and this is 6ax, my bad. Okay. Now all good. And this is 12ax plus 9a square. Always a good idea to double check. 3x whole square, a square, 2 into 3 into 8, that is 6ax. 2x whole square, 3a whole square, 2 into 3 into 2, that is 12. All good. Now first multiply. 4 into 9, 36x square. 4 6 are 24ax. 4 into a square, 4a square. And this is lesser than 4x square plus 12ax plus 9a square. So now let's get things rolling. 36 minus 4, that is 32x square. 24 minus 12, that is 12ax. And then we have 4 minus 9, that is minus 5a square is less than 0. So first of all, 32 into 5, that is 160. And we need 12 as the difference, so 20 into 8. So therefore, this is 32x squared plus 20ax, or we can write minus 8ax first, plus 20ax minus 5a squared is less than 0. This is 8x, 4x minus, this is a. And this is 5a. This is 4x, double check, minus a. Good, is less than 0. 4x minus a. And this is 8x plus 5a is less than 0. Now a number line, a curve, and the roots. So 4x minus a equals to 0, excess a over 4. 4x minus a equals to 0, excess a over 4. Similarly, 8x plus 5a equals to 0, excess minus 5 over 8a. So the smaller value is negative 5 over 8a. It's naturally in terms of a. And this is 1/4 a, which is positive. We are looking for the region which is less than 0, which is the region below x-axis. One single region, one single answer, x lies between positive 1/4 a and negative 5 over 8a. Is it this thing? Final answer is this thing. Just ignore this thing. So that is the answer. And now the last question. Another question like this, which you can do, nothing special. And the last question is this one. So again, this is for later. That is the sketch. My focus is on inequality and equation. Now, this is an equation involving logs. So it's not an inequality. It's just a modulus equation. 2 modulus 5x minus 1 modulus is equals to 3 5 power x modulus. It's kind of 3, but it's an equation rather than an inequality. So I can square both sides. That's one way of doing it. And I can also take care of positive, 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 negative, and all these things. Okay. So keep in mind, if there is modulus on both sides, one option is positive, positive. Other option is negative, negative. Third option is positive, negative. Fourth option is negative, positive. So technically, these two options are the same. Positive, positive is the same thing as negative, negative because the signs will cancel out. Positive, negative, negative, positive is the same thing. So now let me solve this thing separately. First, let me take the positive, positive. So therefore, 2 5 power x minus 1 is 3 5 power x. That's one option. The other option is positive on the left. 5 power x minus 1 is negative of 3 5 power x. Now you can make a substitution for both. Let m is equals to 5 power x. So therefore 2m minus 2 is equals to 3m. 2m minus 3m, that is negative, m is positive 2, therefore m is negative 2. 2 into m minus 1, that is 2m minus 2. 2m minus 2 is equals to negative 3m. 2m plus 3m, 5m is equals to 2, therefore m is 2/5. But what is m? But m is 5 power x. 5 power x is equals to negative 2, no solution. A positive number raised to any power can never be negative. It can never be 0. Positive base, if the base is positive, let me write a base, raised to any power will always be positive. It can never be 0. It can never be negative. 5 power x is 2/5. Take LG or ln of both sides. LG 5 power x is LG of 0.4. X LG 5 is LG of 0.4. X is LG 0.4 divided by LG point of 5. And then they have given the answer as this thing. So that is 0.569. So this is answer is 0.569. Do double check this answer with a calculator, and this is all done and dusted. So that completes modulus inequalities, all the three cases, modulus equations with the true false test, with some unknown constants a, with logarithm. So everything is done. The only thing that's left, that is the modulus sketch, which can be done later. Take care, everyone.